Hi everyone, hope you are doing fine. This is going to be a second video of my system design playlist in which we are going to study about a load balancer. Let's see why. Firstly, we are going to see why we need load balancer, and after that we are going to learn about load balancer in detail. So let's see why we need load balancer. So let's assume you create an app and which becomes viral and reaches around 1 million active users. So initially, everything was working fine, but whenever we reach 1 million active user, we have only one server, so that server become overwhelming with the request. So in that server, we see that there is a high CPU usage, slow responses, and many request timeouts. So these are the problems we are facing. So as the now we have a lot of users, so also there is a single point of failure. So because we run everything or we have only one server. So if that server goes down, our whole application is going to down. So to like so instead of doing a single only hosting a single server, we are going to run the multiple instances of our service. So now we are running three services, like service 1, service 2, and service 3. So and let's assume the we can say the URL domain of your backend service looks something like that. Like for server 1 it looks something like this, and server 2 it's server 2 dot let's say some learnhub.com, and similarly for server 3. So now we done we increase the number of services, but now in the client side, we can say front end, we also have to implement that thing. So because previously what happened, if we have only one server, our URL looks something like that. We can say something we can say simply a learnhub.com/API. Our backend URL looks something we can say starting endpoint look like this. So now what happens? Now we have to implement that same thing in the front end. So by doing this in front end, we are exposing we can say exposing our all these services endpoint in the front end. So this is the first big problem, and also the now our server we can say our client become tightly coupled with our backend services. So in future, if we are going to add more, we can say service 4, let's say we add server 4. Now again we have to make changes in the front end. So this is again a very big problem, because if we have like I also mentioned here, adding a new adding new server, after that every client like front end, mobile app, and desktop need update, because now we have to add that server, and then we have to choose some if we have three server, and randomly choose a one server and make request to that. So this is the problem. And also if we are randomly choosing this thing, there may be possibility that the load distribution is not going to be we can even. There may be possibility most of the request is only hitting a server A or server B. So yeah, another problem is when we don't know, if let's assume our server 2 is down and user are making again request to that, so this request are going to be only timeout. So in the this is also like a failure problem, in which we make going call to server 2, because we don't know is that server is active or not. So yeah so these are the problems which we are facing. So load balancer help us to solve this problem. So let's see what is a load balancer. So as the name suggests, like a load balancer, it is going to balance the load. So load balancer is a component that sit in the, we can say, between client and the server, and distribute incoming request across multiple server, like something like that. So we have something like a client, and we include we add a load balancer in between client and the server. Now every request will going to client through this load balancer. So the now this load balancer will balance all the it can keep track of things like how many requests I have given to server A, like the number of currently the request that server 1 is serving, something like that, so that it can balance the load in a proper way. So by doing this, like we like what are the, now let's see what are the benefit of the load balancer. So first benefit is like high availability and the fault tolerance. So now let's assume like we have now three servers and our one of the servers go down. Let's say this is a down. Server 3 goes down. So now not load balancer knows that the server 2 is down. So load balancer will not send any like we can say forward any request to the server 3. So now load balancer only forward request to server 1 and a server 2. But if we are using only one server, so in that case this is going to be like down, and we have like our whole application is down. So yeah, so now like now how will the load balancer will know that is the load like this server are active or not? So there are two kind of like we can say approaches like a load balancer do to check whether a service is up or not. So first thing is like active health check. So in this what happen is like a load balancer like proactively checks the health of the backend server at regular interval. So in this kind like we can whenever we create our like a API for server like server, we can we create a something like a health slash health API slash API slash health. So now this will return response like something like 200 like status of 200, and like we can say something we can also write message like message like service is we can something like service is up, something like that. So now whenever load balancer make call to this API, whenever like in case of error, this load balancer will not see this response. And after like we can configure like whenever we don't like whenever our backend service will not respond for consecutive three or more requests, we can mark that server as a unhealthy server. And second like second method is passive health check. So in this method like load balancer is not going to make a call to a backend server again and again. So in this like so what happen in this case whenever simply we have a something like a client uh, we can say we have a client, and whenever like a client make a request to our we can say load balancer, this is our load balancer. So now whenever load balancer forward the request to the any server, it will keep track like whether this like we can say whenever a load balancer make a request to the server, it will keep track whether the request is like served by a server or not. So in that case load balancer will keep track like if the more than three or four consecutive requests from same server are marked as a like we can say timeout or something like error, we can mark that server as like this is an unhealthy server, so we can remove, and we will not forward any more requests to that server. So yeah, and the second problem is like horizontal scaling like we are facing like whenever we are adding like in this whenever we have to add that server add one more server, we have to update we have to give update on every client. So by doing like whenever when we have a load balancer in between client and server, we can like add or remove as much server as we want, because like client is only talking to load balancer. So like these are going to be like we can say client don't know about these services, so we can add or remove, and load balancer will all keep track of this thing. And the third thing is like intelligent routing. So in this case what happen like whenever we do some it from front end, so like we are choosing some random number, we can say we are generating some random number between 1 to 3, and then forwarding that request to that server. So but in case of load balancer we can use a different type of algorithm like we have something like a leash connection. So in that algorithm we are like a load balancer maintain the like the number of connection that like every server has with the load balancer. So and check and like if the new request come it will check like which one has a least number of request, and then send that forward that request to that server. So yeah, so like at the end of the video we are going to see about different algorithm for the rate we can say load balancing. So yeah, so now another like a fourth benefit of the we can say the load balancer is security and centralization. Like Now you can see in this case we have to expose our like all the services to the front end, so anyone can see like what are different types of services we are running and how many instances, etc. So yeah, so instead of doing now we have only like you can see only one load balancer exposed in a public. So yeah, so like we reduces the like attack surface, and also we centralize SSL and TLS termination. So like we can also run this something like this in a private network. So like this is something like this run in our private network, and only this load balancer is exposed to the public. So after that, whenever like load like we have two types of load balancer, L4 and the L7. So in case of L7 we can also we can say we can do encryption and decryption in load balancer also, so that server don't have to do heavy lifting. So yeah, so now let's move to the types of the load balancer. So like on the information, does the load balancer inspect like how much information load balancer inspect before making the routing decision? So like on the basis of that we have two kind of the load balancer. So first one is the layer 4 and the second one is layer 7. So before learning about like L4 and L7 load balancer, you must know about like OSI model. So in OSI model, we have 7 layers. So first one is like a application layer, second one is presentation, third one is session, and the fourth one is transport layer. So we only required like we can say about like we only need to learn about we can say the L4, L4 and the L7 for this like load balancing thing. So like L7 is the like layer where the like it includes the matter like HTTP, SMPT, which actually l- like this layer is the closest to the like application. So this is the actual layer which talk to the application. So like in this layer like we have HTTP and SMPT. So what happened like in this all the like we have something like headers, cookies, etc. can be accessed in this layer 7, because in the layer 2 like in the layer 2 in presentation layer we encrypt like encrypt and decrypt the data. So after that the data is going to be like encrypted. So so in like a layer 4 that transport layer, so the functionality of this transport layer is to simply like send the data between two devices. So it doesn't know like anything about the like like method, we can say cookies, etc. Because like in this the data is encrypted and so yeah, so I think that is like that's enough for the OSI model, because it is like I think we require that much only. So let's move to the L4 load balancer. So like L4 L4 operate at layer 4. So like L4 operates at transport layer. So at this layer communication happen, and like at this layer communication happens, and load balancer only know like what is the source IP from where we can say the packet are coming, and destination IP, and the source port and the destination port. And like this like transport layer uses TCP and the UDP protocol for sending the data. So like as I already discussed, L4 does not inspect like a application payload like HTTP parsing, we can say header inspection or a cookie inspection. Only like so it can simply do like a we can say the simply simple level of like we can say alpha load balancer simply check the source IP, and we can say the balance the load on basis of that. Like it can simply track the different like IP, and it can simply route the basis of that IP, or we can say or it can simply do like a round robin algorithm in which we send the like first request to first server, second to the second, and the so on. So yeah, so yeah, like L4 only route like traffic based on like a different algorithm like IP hash or least connection or round robin. Like since like L4 does not inspect the application payload, so it cannot perform URL based routing. So let's say we have something like we have to perform routing like we have three services, something like we can say for auth we have to send request to the auth like we can say auth. or service. So this can't be done by we can say L4 load balancer, because it it doesn't know anything about the we can say URL or cookies or anything. So yeah, so due to this, this become very fast. So it doesn't have to we can say inspect anything. So due to which also smaller attack surface, because application payload is not inspected, we can't inspect that. So but a disadvantage of this is like a dumb routing. So we can let's say we have something like a we want two server running. First one is like a bigger server in which a premium user can make request, and second one a normal server where a free users can make a request. So we can't do something like that. So now let's move to the L7 load balancer. So the L7 load balancer operates at application layer. So as L7 operates at application layer, it can see the entire payload, HTTP headers, URL, cookies, browser type, and the actual message data also. So as L7 load balancer so what happen is whenever L7 L7 load balancer receive a new request. So let me draw here. So we can say we have something like L7 load balancer. So what happened L7 load balancer do whenever someone make a request, it terminate that request and then create a new, we can say, new TCP connection from a load balancer to a service. So due to which a load balancer can track the number of we can say active requests that service is serving, and a lot more things. So on the basis of that, a load balancer can do a lot, L7 load balancer do a lot of smart, we can say a much smarter routing than a L4 load balancer. So yeah, so what are the pros of the load balancer L7? So we can do something like a intelligent routing, based on URL path headers and API endpoint. So API endpoint. So second thing is SSL offloading. So as this work at L7, we can say application layer. So instead of simple, so we can simply as these services are going to be run in our private network, so we can simply make we can simply send a decrypted data from L7 to the service layer. So have all the heavy lifting of encryption, decryption is done by L7. So another thing is as so yeah, so that's pros of this L7. And now let's move to the cons of the L7. So this is going to be a resource intensive, because it's have to do a lot of processing, and also it is a slow than L4 load balancer. So now let's move to the load balancing algorithm. So the first one is the round robin. So in this algorithm, what happen whenever a load balancer receive a request, it first send the first request to the server one. So let's say we receive first request, we send it to the server one. Then we receive second, it sent to the second. Then receive third, it sent to the third. And now we have only three service. So for the fourth request, it again sent to the server one, fifth to the server two, and sixth to the server three. So this is one of the basic we can say algorithm for load balancing. Like some of the pros of this are we can say it is very easy to implement, and some of cons are there may be a chance if, let's say, if our server 2 is we have a server 2 is very big. So it has, we can say, 32 GB of RAM, and server 1 has only 16. So server 2 can process more requests than server 2 can process more requests than server 1. So in that case, we are not utilizing the complete power of the server 2. So yeah, to solve this problem, we have something like a weighted robin. So in this in this algorithm, we can assign a different way to the algorithm. So let's say we assign, we can simply a number from 1 to 10, but for easy for explaining purpose, I do, mark it as a be the percentage, or we can say if we are receiving like 100 requests, among that 50% 50 requests must be served by one like server 1, and 20% by server 2, and the 30% by server 3. So now whenever we reach something like first request, it may serve to 1, and if we again reach second, a load balancer again send to the 2, because in the overall, like if we send 100 requests, we want like at least 50% to our server 1. So yeah. So third algorithm is like a least, like these are static, like because we can't change this this algorithm on the basis of the traffic we are receiving. So like these are the dynamic, like this third one, like a least connection. This is a dynamic, we can say, load balancing algorithm. It can like balance we can say route traffic to the server, like in this the load balancer route traffic to the server with the least we can say least number of open connection. So let's say if we have server 1 has 100 active connection, and server 2 has 30, and the server 3 has 50. So now the whenever new request is arrived, we send to the server 2 because it has a less number of active connection. So yeah, that's it for this least connection. And we have fourth algorithm, which is a weighted least connection. So like this is a combination of we can say least connection and the we can say weighted round robin. So it in this we instead we make a like decision on the basis of like a active connection, but we also take like consideration of the weight of like we can say like it must have 60% of the active connect 60% of connection. But if it has 100 connection, and server 2 has 40, and the server 3 has 50, so whenever new request come, we will send it to the we can say server 3, because whenever we if we are calculate like, because this is not going to be a simple calculation like who has number maximum number of the we can say active connection, because we have also give the consideration to this weight also. So yeah, so the fifth algorithm is like least response time. So in this way, like in this algorithm, the load balancer have to manage the we can say average of the we can say for the last 5 minutes or the 1 minute, the server maintain the what is the latency of the server. Like if we can say the latency of server is 200 millisecond, server 2 is 40 millisecond, and the server 3 is 35. So whenever new request come, we will send it to the server 3 because it's responding us fast. So yeah, so the sixth algorithm is like IP hash. So in this, what happen we can we take the IP address of the client, and we pass it to the hash function, and from that we get the value between the like if we have something like like 1 to 5 server, we get a like a number between 1 to 5, and we can serve that IP address to we can say that server only. So in this way, the same client IP is always routed to the same server. So the IP address algorithm help us into enabling sticky sessions. So in the if you know about WebSocket, in case of WebSocket, we want this sticky session. So we want like if user one is connected to server one, if he again connected, like we can say it refreshes the page. Here like a user refreshes the page, we want that user to again connect to that server only. So but the problem is the problem with this is like whenever we add or remove a new server, like let's say we made this server to a 4, so now the like hash result of this IP will be changed for every every server. So we have to do a large number of mapping. There may be possibility like some IP address get the same number, but in most cases it's going to be a different. So to solve this problem, we have a concept like name as a consistent hashing. So which minimizes the like a remapping thing and ensure that only a small number of users are affected when servers are added or not added or removed. So yeah, there are some example of we can say the load balancer. First one is the Nginx. Like Nginx can also be can serve both as a API gateway and a load balancer also, and something like HA proxy Envoy, and we have something like AWS load balancer. We can say like AWS application load balancer, like which work at we can say L7 layer, and something like a network load balancer which work at L4 layer. So yeah, that's it for the video. I hope you like the video.